Hello everyone. Today we are going to learn a little more of the Unit 1 Mathematics HL. So I'm gonna start off with quadratics. So the equation for quadratics is ax squared plus bx plus c. In this case, this is quadratics because it has x, and the ABCs are real numbers. So there are two different kind of quadratics. The first one is ax squared plus bx plus c equals to 0, which is the quadratic equation. And in this case, we might have roots. Roots means answers. And the other one is fx equals to ax squared plus bx plus c. And this is the quadratic function. And in this case, we get graphs, parabolic graphs. Okay, so let's start off with learning how to determine A, B, and C. So in this case, we have an example of negative 2x squared plus 7x plus 5 equals to 0. Okay, let's determine A. As we learned the equation ax squared plus bx plus c. So it should not be that hard to determine A, B, and C. So in this case, A is negative 2, B is 7, and C is 5. How about this case? This is not rearranged yet, so we need to first rearrange it. So it would be 5x squared. We move these to the other side of the equation, which would be plus 2x minus 3 equals to 0. Now that we rearranged it, we need to determine A, B, and C. A is 5, B is 2, and C is negative 3. Okay, and there is a note that you need to know, which is in order to determine A, B, and C of a quadratic, we need to gather terms to one side and the other side supposed to be 0. That's what we did in this case. Okay, now let's move on to the next topic, which is 3 ways of solving quadratic equation. So there are 3 ways of solving quadratic equations, and the first one is factoring, the second one is completing the square, and the third one is quadratic formula. So let's take a look at each one by one. So first, let's take a look at factoring. Okay. In order to factor, first we need to gather all the terms to one side. Then second, we would factor, and third, when we're done factoring, we would use the null factor law, which is if a times b equals to 0, then a equals to 0 or b equals to 0. Okay, this is how it's done. So first, we need to gather all the terms to one side and the other side should equal to 0. In this case, this already happened. All of the terms are on one side and the other side equals to 0. So let's move on to the second step, which is factoring. So this is how I like to factor. I do the cross here because this is x squared. This would be x times something and x times something. These two somethings are the numbers that give us 2. So what times what gives us 2? Let's take a look. 1 times 2 gives us 2. So we would put 2 on this and 1 on the one below. So now we need to see if we add 2 and 1, do we get 3x? Okay, let's try it out. X times 1 is x, and x times 2 is 2x. So we know that by adding or subtracting these two, we need to get plus 3x. Let's see what signs do we need to put here in order to get 3x. So this, if there's a plus here and if there's a plus here, we know that by adding them we would get 3x. Okay, that makes sense. Okay, so let's put a plus here and a plus here. So now, if you take a look at this, we see that x plus 2 and x plus 1. Okay, let's write it down. X plus 2, x plus 1. That's it, we just factored. See, if you time this with this, and this with this, and this with this, and this with this, we would get the whole equation right here. Yes. So, okay, we just did the second step. Let's move on to the third step, which is using the null factor law. Okay. Wait, we forgot equal to 0 right here. Okay. So, x plus 2 equals to 0, or x plus 1 equals to 0. This is the null factor law. Okay, let's figure it out. X equals to 2 and x equals to -1. That's it. These are our two answers. That's it. This is factoring. It's this easy. Okay, let's do a little more examples. Okay. Now it gets a little harder here. We see that we have, as a, we have 2 right here. First, we need to see if all of the equation can be divided by 2. If yes, then it would be so much easier to solve it. So let's see. Can we divide 6 by 2? Yes. But can we divide 4 by 2? That's a yes too. So in order to make the whole equation easier, we would divide this by 2. Divide the whole equation by 2. So, okay. 2x squared divided by 2 plus 6x divided by 2 plus 4 divided by 2 equals to 0. This gives us x squared plus 3x plus 2 equals to 0. Okay, let's factor again. X and x. What times what gives us 2? 2 and 1 gives us 2. Now let's figure out the signs that we need to put in order to get 3 plus. A plus here and a plus here would do it. So it would be x plus 2 and x plus 1 equals to 0. So x plus 2 equals to 0, or x plus 1 equals to 0. X equals to -2 and x equals to -1. Yay, we got the answers. Oh, and sorry, the last equation, it was -2. I forgot the sign. Okay, so now we figured out that if the whole equation can be divided by the a, then we should do it in order to make the equation easier. But how about if we can't divide it by the a? Okay, let's take a look at another example which we cannot divide the equation by a. Okay, so in this case we have 7x squared minus 32x minus 60 equals to 0. We see that 32 and 60 cannot be divided by the a that we have, which is 7. So we try to solve it with having the 7 there. Okay, so let's factor it. It would be 7x and x. We see that this 2 give us 7x squared, right? Okay, so now we need to see what times what gives us 60. 10 times 6 gives us 60. Let's try it out. 10 times 6 gives us 60. Okay, but then right now we need to figure out the 32, negative 32. Okay, let's see. If 10 and x gives us 10x, and if 6 and 7x gives us 42x, do we get negative 32x? That's the question. Yes, we do. But then if I did not place 6 here, and if I placed 6 up here and 10 right here, we would have not gotten 32x, because 7x times 10 gives us 70x, and 6 times x gives us what? 6x. This does not give us negative 32x. So you need to be careful about the placement of these two numbers. You need to place it at the right position. We know that this here and this here would give us 32x. Okay, so let's do it. 6 times 7 is 42x, and 10 times x is 10x. And we need to figure out the signs now. Okay, if we put minus here and minus here, that would give us 52. No, we do not want 52. So how about if we put a plus here? Yes, we would get 32. Negative 32x. Okay, now let's do the question. Let's put the minus, no, let's put the plus here and the minus here. So now we need to look at it in this way, cross each other. So that would be 7x plus 10 and x minus 6 equals to 0. Okay, 7x plus 10 equals to 0, or x minus 6 equals to 0. 7x equals to negative 10, or x equals to 6. X equals to negative 10 by 7, or x equals to 6. These are our two answers. So now we know how to solve the equation if our a is not divisible by all the numbers in the whole equation. Okay, let's move on to the next way of solving the quadratic formulas. So the next way is by completing the square. So first, let's discuss the steps of solving a completing square equation. Okay, so if we have ax squared plus bx plus c, the first step is to check the coefficient of x squared. So the first step is to check the coefficient of x squared. Of x squared. You can do this by first checking if a equals to 1. If yes, then done. you can skip this step. But if not, then you need to see if a does not equal to 1, then we need to make it we need to divide all the terms in the whole equation by a. So then make it 1 by dividing, I missed out, the spelling is wrong, all the terms by a. Okay, when this step is done, you need to move on to the second step, which is make constant number to the other side. So move the constant number to the other side. So x squared plus bx by a equals to negative c by a. So we divide all the numbers by a, right? Okay. So now that we divided by a in the first step, we move the constant number, which is plus c by a, to the other side, which made it negative c by a. Okay, now the third step. The third step is to complete left hand side to the square and right left hand side as a perfect square, and take square root of both sides. So you need to complete the left hand side, okay, to the square, and write the left hand side as a perfect square. And then when you did that, you need to take roots of both sides. I would show that in the examples that we're going to have. So also that you should be careful when we take the square of the root. We have two cases, because root is plus and minus, right? So we would have two roots. We would have two answers, which would be plus something and minus something. So don't forget about the plus and minus of the roots. And then the fourth step is to leave x alone. Yeah, that's pretty much all the 4 steps. Now, okay, so now let's take a look at how to do squaring method. We've discussed the steps, but it's better to do examples. It helps you better understand the topic. So here there's an example. So the first thing you need to do is to move 15 to the other side. So it would be x squared plus 8x plus the new c equals to the new c minus 15. Because when we move 15 to that side, it would be negative. So now how to find the new c? So we would always take b, which is 8 in this case, and divide by 2, which would give us 4. And when you get the answer, you square it. So it would be 4 squared, which equals to 16. So basically it's b divided by 2 square. That's how you get the new c. Okay, so it's the formula in order to find c is b divided by 2 square. That's what we did here. B is 8. We divided it by 2, which we got 4, and we squared 4, which we got 16. So now the new c is 16. So it's x squared plus 8x plus, 16 equals to 16 minus 15. This would be x squared plus 8x plus 16 equals to 1. Okay, now you do the cross multiply factoring, which would be x and x, 4 and 4, plus 8x. That means this should be plus and this should be plus. So it's x plus 4 and x plus 4 equals to 1. Since they're both the same, you would write x plus 4 square equals to 1. Let's erase out some. So now you take a root for both sides. X plus 4 square equals to root 1. I'm gonna continue on this side since we don't have space. So the square and the root here cancel out, so it would be x plus 4 equals to plus or minus 1. So in this case we would have x plus 4 equals to plus 1, or x plus 4 equals to negative 1. And this would be x equals to negative 4 plus 1, or x equals to negative 4 minus 1. So the answers are x equals to negative 3 or x equals to negative 5. So that's how you do it. Okay. And now let's move on to x squared plus bx. So if we have x squared plus bx, in order to make a perfect square, we need to add squares of half of coefficient of x. So basically, okay, this is how you do it. Okay, if we have an example of x squared plus 6x, you see that it's a x squared plus bx. We only have x squared and we only have bx. So what we do is that we know that we want c, right? So it's x squared plus cx plus question mark. We don't have c. So what I do is I use the b by 2 square formula. So it would be 6 by 2 equals to 3, and when you square it you would get 9. So it would be x squared plus 6x plus 9, where if you do the cross multiplication you will see that it's a x 3 plus 6x, so this would be plus and this would be plus. So here we would have x plus 3 and x plus 3, so we would have a x plus 3 squared. That's it, pretty much like the last one, except that you don't have the equal to 0 on this side, so you don't have to solve it out till the very end step. Okay, and okay, so now let's move on to the quadratic formula, the third way of solving a quadratic equation. So here we know that in x1 and x2 we have a formula which is negative b plus or minus the root of b squared minus 4ac divided by 2. So this is the quadratic formula. Yeah, and It's not really hard. All you have to do is determine A, B, and C, which we learned in the beginning, and then you substitute it in the formula, which would give you the answer. Okay, let's solve out a problem right now. Okay, so first step is to move all the numbers to one side, and the other side should equal to 0. In this case, it's already like that. So the second step is to determine A, B, and C. In this case, A is 2, B is -5, and C is 1. So now let's write down the formula. Negative B plus or minus root b squared minus 4ac divide by 2. So this equals to negative, since there's a negative here and negative here, you should write them separately because they have nothing to do with each other. They're different negatives. So what is b in this case? It's -5. So you just substitute it. -5 plus or minus root. What is b here again? It's -5 squared minus 4. What is a? 2. What is c? 1. Divide by 2. Oh, forgot the a. Oh my god. Forgot the a. So sorry. Okay. 2a. Okay, so what's a here? It's 2. Okay, so now let's solve it. Okay, negative times negative, it's positive. So 5 plus or minus, what is -5 squared? It's 25 minus 4 times 2, it's 8. 8 times 1 is 8. So 8. 2 times 2, it's 4. So equals to 5 plus or minus 25 minus 8 is 17 divided by 4. So we know that there is no root for 17, so you can just leave it like this and write x equals to 5 plus root 17 by 4, or x equals to 5 minus root 17 divided by 4. So these are the two possible answers. Or you can continue and use a calculator and find the root of 17. It's up to you. So if you want us to do one more question, we can. Just wait a second. Okay, now let's move on to the discriminant of a quadratic. So the definition of this is, let me write it down. B squared minus 4ac is called as the discriminant of a quadratic. I'm gonna make it a short form. So in this case, sorry, I forgot the delta here. Sorry. Okay. In this case, the formula is delta equals to b squared minus 4ac. Delta is the discriminant. It stands for discriminant. So delta stands for discriminant. So that's why we have the formula like this. Stuff that you should know about the delta, the discriminant. So if delta is greater than 0, that means there are two different roots. Like x1 equals to -b plus root delta divided by 2a, or x2 equals to -b minus root delta divided by 2a. Okay, this does not mean that if you get something like x plus 4x plus 4 equals to 0, that means it's x plus 2 and x plus 2, which would give us x equals to negative 2 or x equals to negative 2. This does not apply to this rule. It does not apply to this rule at all, because even though we get two answers, we're getting two different answers. Though this applies to what I'm going to talk about next, which is the second rule, which is if delta equals to 0, that means there is, what's happening, is only one real answer, real root. Okay, so in this case there are actually two roots, but then they are the same, like just like what I explained in this case. See, we got two answers, but they're the same, so that means it's the same thing. Okay, now let's move on to the third one, which is also that in the last case, it's something like x equals to negative b plus or minus root 0. So if you have this, then you would get the second form, second rule or whatever. Okay, and the third one, it's delta is, if delta is less than 0, that means there is no real solution. Okay, now let's now let's do some examples. Okay, if we have x squared minus 6x plus k, and they ask us to find which k value of the equation has a 1 root, b 2 roots, and c no root. So we would first check with a. So a is delta equals to 0, which means it's b squared minus 4ac, right? Because this is the rule. So what is b in this case? It's negative 6. Negative 6 squared minus 4, a is 1, and c is k. So 36 minus 4k gives us 4k equals to 36, which means k equals to 36 by 4, which is 9. So k equals to 9. So in the delta equals to 0 situation, k equals to 9. And now for the second one, which is b, let me erase off. We have b for delta is greater than 0. So b squared minus 4ac equals to 36 minus 4k is greater than 0. So 36 by 4 is greater than 4k by 4. So 9 is greater than k. Can you see this? Yeah. And now for the last situation, for c, we know that in the no root situation, delta must be less than 0. So that would be 36 minus 4k is less than 0. So 36 by 4 is less than 4k by 4. So 9 is less than k. Okay. Okay, now let's do a real question. They might ask you something like 2x squared minus 6x plus 11 equals to 0. And they would ask you to find out the number of solutions. So what you do is that, in order to find the number of solutions, you need to use delta equals to b squared minus 4ac. So let's find how many solutions we have in this equation. So we know that b is negative 6, so square it, minus 4 times 2 times 11. So 36 minus 4 times 2, which is 8. 8 times 11 is 88. This gives us negative 52. Delta equals to negative 52. So now we know that delta is less than 0 because it's negative, right? So this means that there are no roots, no solutions. Okay, now let's move on to the the other topic, which is graphing quadratic functions. Okay, the formula for this is f(x) equals to x squared plus bx plus c. If you remember, we learned the quadratic function in the beginning when I was explaining the quadratics, right? So basically this is the transformation of y equals to x squared. Okay, this usually gives you parabolic graphs. So graphs which are parabolic. Now let's learn a little more about the graphs. I can use a ruler, but then never mind. Okay, so let's draw a parabolic graph. Let's draw it with the red. Okay, so we know that in this case we have an axis of symmetry, which is the line that goes through the vertex point. Okay, this is the axis of symmetry. And the vertex point is right here. The vertex point. Basically, the vertex point is the turning points. Usually in the parabolic graphs is the minimum point, is the lowest point that the graph can have. Then we also have this point, which is the y-intercept, is the point that cuts graph at the y-axis. And then we have here the x-intercept. Though we have two x-intercepts because the graph cuts the x-axis at 2 points. So the x-intercept. And pretty much that's it. And we know that this is y and this is x. Okay, and there's some notes that you should know, which is okay, note. If f of x equals to ax squared plus bx plus c, if a is greater than 0, the graph would go upwards, which means the graph would be something like this. Though if a is less than 0, which means if a is negative, the graph would be downwards. Which means it would look like this. So this would something be like gx equals to negative fx. Okay, let's look at some examples right here. I'm gonna write it very small. So if f of x equals to negative 4x squared plus 5x plus 3, I don't know, this would be what? This would be downwards, because a right here is negative. Can you see the negative sign? Yeah. Though if f of x equals to 4x squared plus 5x plus 3, we see that there are no negative points here. A is greater than 0, so the graph would be upwards like this. I hope it's clear. And there's some more stuff you should know. It's that if more notes it's that in order to sketch parabola, we need to know first of all the x-intercept. So in order to sketch parabolic graphs, these are the stuff we need to know. X-intercept, we need to know if x-intercept exists. So if yes, then the second thing you should look at is the y-intercept. And then the third thing we need is the vertex point. So these are the stuff you need to know. Okay, let's move on to the next thing that we should know. We should know that the different forms of quadratic function. Okay. There are different forms of quadratic function. The first one is y equals to a x minus p and then x minus q. And the second one is y equals to ax squared plus bx plus c. And the third one is y equals to a of x minus h squared plus k. So the first thing we should look at is the first form, which is y equals to a times. Now let's move on to the first form, which is y equals to a times x minus p times x minus q. So in this case, p and q are real numbers. So p and q are real numbers, and we use the three forms right here in order to find the x-intercept, y-intercept, and vertex point, because those things are the things we need in order to sketch a parabolic graph. And this whole topic is about graphing quadratic functions. So in order, first let's take a look at x-intercept, how to find x-intercept using this form. So in this case, in order to find the x-intercept, you should just look at P and Q, because P and Q are the x-intercept. So P and Q. Let's take a look at an example. Okay, something like f of x equals to 4 times x minus 2 and x plus 3. Okay, so in this case, our x-intercepts are 2 and -3. Oh, -3. Okay, when you look at P and Q, you need to change the signs, because when you graph it, it's not +3, it's x plus 3. So when it's x plus 3, you're probably moving to the negative side. So just remember that you need to change the signs here. So if it's minus, you change it to plus. If it's plus, you change it to minus. And then the second thing you need to know is finding the y-intercept using this formula. So okay, so the second thing is y-intercept. I don't know what's wrong with my pen, but okay. So in order to find the y-intercept, you need to replace the x with 0. Okay, so you need to replace x with 0, and then you will get the y-intercept. Okay, let's try it out. So if it's f of x, which means it's y, equals to 4 times x minus 2 and x plus 3. Okay, this would mean that 4 times 0 minus 2 and 0 plus 3. So 4 times -2 and 3, which would give you 24. So this is y right here. It's the y-intercept. Okay, it's just easy. This is, you just replace the x's sounds like axis, with 0. Okay. Now the third thing you should know is how to find the vertex point. How to find vertex using this form. So the average of x-intercept gives us the x coordinates of a vertex point. Then we replace this number with x, and we get y coordinate of vertex point. So basically, there are formulas which you use in order to get the x vertex and y vertex, because there are different vertex points. And what did I just say? Okay. Okay, let's forget this. Okay, so in order to find there are formulas in order to find the vertex, and let's show it on the graph. Okay, so if this is Oh god, I am drawing it wrong. Oopsie. Oh, forget this 3 right here. Okay, so let's start over. Okay, now the third point, which is the vertex. In order to find the vertex using this formula, they're using this form, their formulas for it, which is v equals to p plus q divided by 2. Okay, and if you want to find the y coordinate of the vertex point, you have the formula of f of p plus q divided by 2. So this is used to find the x coordinate of the vertex point, and this is used to find the y coordinate of the vertex point. Okay, let me show it on the graph. So basically, if you have a y-axis and an x-axis, and if this is the axis of symmetry, and if this is your graph, let's just say this is your graph, this point, it's your x vertex, x coordinate of the vertex. So I'm just gonna write as vx, and this point right here is the vertex, right? Okay, let me draw it with another color. So if this is the vertex point, if you see, this would be the x coordinate of the vertex, and right here would be the y coordinate of vertex. So vy. And for vx, we use the formula of p plus q divided by 2. And for this, we use the formula of f of p plus q divided by 2. So whatever we get here, we just replace it with inside this. And f means that we substitute this in the whole equation. Okay, let me show some examples so maybe we can understand better. So if we have to, let's just solve for all of them. If the example says y, or f of x, equals to 2x x minus 1 and x plus 2, and it says sketch the graph, what you do is that first you find the x-intercept, which is plus 1 and minus 2. Why? Because we have q and p, right? Here we have p and q. So those are the x-intercepts. Easy first step. Okay, second step is to find the y-intercepts, which are the, let me write intercept, and this is y-intercept. So in order to find the y-intercept, I told you to replace x with 0, right? So it would be y equals to 2 times 0 minus 1, 0 plus 2. So it's 2 times negative 1 times positive 2. So it's 4, negative 4. So y is negative 4. Okay, and the third step is to find the vertex. Okay, vertex. So now this is the tricky one. I'm gonna erase y and x so we would have more space here. Okay, so first let's find the vertex of x. Okay, it's easier to find that first. So it's p plus q divided by 2, which means -2 plus 1, right? Because I told you to change the signs right here. So it would be -2 plus 1 divided by 2, which is -3 divided by 2, which you can oh sorry, it's -1 by 2. So this is our x coordinate of vertex, and for the y coordinate of vertex you use the formula of f p plus q divided by 2, which means that you replace this inside the whole function, which would be like this: y equals to 2 times -1 by 2. So you replace it with x because it's the x. You replace it with x because it's the x coordinate, minus 1, and then -1 by 2 plus 2. So it would be -2, -3 by 2, 3 by 2. So this and this cancel. You would get, I'm gonna write it here, -9 by 2. So this is the y coordinate of the vertex point. See, it's not that hard after all. So now you should sketch the graph, right? After all, they asked you to sketch the graph. But we had to find x and y in order to sketch the graph. So this is a normal graph. Now we know that our vertex point is -1 by 2 for x. So let's say this is -1 by 2. I'm gonna change the color. -1 by 2. So this would be the axis of symmetry too. And the y coordinate, it's -9 by 2. So this would be the turning point of the graph, the vertex. And this would be the y-axis, where the y-axis was -4, right? So this would be the y-axis, and then it goes up like that, and then it goes up like that. And as our x-axis, we got -2 and 1. So that pretty much is it. So now let's move on. Oh, sorry, I should have not erased the graph. So now let's move on to the second form, which is y equals to ax squared plus bx plus c. Oh, also remember that in the first form, second form, and third form, if a is greater than 0, we get the upward graph, and if a is less than 0, we get the downward graph. Just like what I explained before. Okay, just a reminder. Okay, so now in this form, in order to find x-intercept, you use the formula of negative b plus or minus root delta divided by 2a, or we can use any method to find zeros of the function, or we can use any method to find the zeros of the function. Since this is the quadratic formula, you can just do the normal thing and use the quadratic formula to find the x-intercepts. Okay, and in order to find the y-intercept, I'm gonna erase this out. Okay, in order to find the y-intercept, which is the second thing you need to find, y-intercept, you again replace x with 0, so replace x with 0, 0, so it would be like this, y equals to ax squared plus bx plus c, right? So if you replace x with 0, it would be y equals to a times 0 square plus b times 0 plus c. So basically all you'll be left with is c. So if you don't want to do this whole thing, you can just look at c from the beginning, and that would be your y. It's that easy. And then for the third thing you need to find is your vertex, of course. So vertex, so as like the other one, there are formulas for the vertex points. So for the x coordinate of vertex, the formula is negative b divided by 2a, and for the y vertex, it's function of the negative b by 2a. So basically, first you'll find this, and whatever you found, you just replace it with the x's, the x of the formula in the function. So you just replace it with x and solve the equation. Okay, so let's do an example for this one. Okay, so example, if we have y equals to x squared minus 4x plus 3, and they ask us to sketch the graph. Okay, so first thing is the x-intercept, where we know that we have to do the whole quadratic formula thing. But then there's another way. You just turn this into the you just turn this into, what is it called, the forms where you have something like x plus something, I don't know, 6, and then you have x plus 3. You just turn that into one of these. How you do this one is, or you can, yeah, in order to do that you can just use factoring. So it would be 3 and 1, so it would be negative 4x, so negative. This one would be x minus 3 and x minus 1, right? So your your x-intercepts are 1 and 3, right? It's just like the p and q thing. You can do the same way, because I said you can use any way just to find the x-intercepts. Okay, and then the y-intercepts, you replace x with 0, or you don't need to do that. Just look at c from the beginning, which is 3, so y-intercept is 3. And for the vertex points, if you do if you follow the formula, which is negative b by 2a, I think. Yeah, negative b by 2a for the vertex x, you'll be left with negative 4 and 2 times 1, so you would be left with 4 by 2. So the vertex x equals to 2, and for the y1 you replace 2 with the x, so it would be 2 squared minus 4 times 2 plus 3, so it would be 4 minus 8 plus 3, and you would be left with -1. So y vertex is -1 and x vertex is 2. Don't forget the formula is like this. Okay, so now let's move on to the third form, which is this. By this, I mean y equals to a times x minus h, it's not n, it's h square plus k. So for this formula, in order to find also that this formula is called the vertex form. This form is called the vertex form. So for this one, in order to find the x-intercept, you need to find the zeros of this formula by using any way. So basically find zeros by using any way. I can show you later in the examples I give. And then for the y-intercepts, you need to replace it with 0. Oh, replace x with 0. And for the vertex form, basically in this one, it's not that hard to find the vertex form because it's pretty much given in the whole thing. The vertex point is the h and k, so h and k are the vertex points. Okay, now let's do an example so you would understand better. Let's take a look at an example. Okay, so where is the pen? Oh, okay, so here's example. It's sketch y equals to negative x plus 1 square plus 2. So in this one you don't really have to find the x-intercepts, just the y-intercepts are important. So the y-intercepts, I said that in order to find the y-intercepts you need to replace x with 0. So what you would do in this case is y equals to negative 0 plus 1 square plus 2, so negative 1 plus 2, which would be 1. So in this case the y-intercept is 1. Now let's take a look at how to find the x-intercept, the vertex points, the vertex. And I said here h and k give you x-intercepts, right? So here, this is h and this is k. So the vertex are -1 and 2. Yeah, in this one, the one that is inside the bracket, if you open it up, it would be -1, right? So yeah, and this would be 2. So these are the vertex points, and if you want to sketch the graph, it would be something like this. Okay, since the since the y-intercept is 1, since the x-coordinate of vertex is 1, the axis of symmetry is 1 too. So axis of symmetry is x equals to -1, which would be here, right? So this is the Vx, and Vy is 2, so it's somewhere here. So this is a turning point. So the graph would be something like this. Okay. Now let's move on to conversion of the second form to the third form. Okay, what I mean by this is converting y equals to ax squared plus bx plus c into y equals to x plus h squared plus k. So the best way to explain this is by doing examples. So let's do an example. Here, if we have y equals to x squared plus bx plus 4, and they asked us to write it in the vertex form, which means this right here, what you do is that you basically kind of use the completing the square method, but then we don't have the other side of the equation, so you just skip it on the same side of the equation. So it would be like this: x squared plus 2x plus the question mark c minus the question mark c plus 4. So 2 divided by 2, because b is 2 here, so 2 divided by 2 square gives you 1. So you just replace the question marks with 1. So it would be x squared plus 2x plus 1 minus 1 plus 4. So you kind of this equation right here is, let me change the color so you won't be confused with one. This equation is kind of separated right here. So you change this into this, and then the plus k would be this right here. So it would be x plus 1 square. So in order to get this, you can just use this side of the equation and do the factoring, which would be x times 1 times 1, which would give you plus 2k. So it would be x plus 1 square, and minus 1 plus 4 gives you plus 3. So basically you're left with this. So is this the vertex form or not? Yes, it is. That's it. It's this easy. Let's do one more example. So if they give you something like y equals to x squared plus 4x plus 5, so the first thing you would do is do the question mark part. X squared plus 4x plus question mark plus 5, sorry, wait, minus the question mark plus 5. So here, this is the separated part, right? This is the k part. Okay, so now we would take b, which is 4. 4 divided by 2 gives you 2. When you square it, you would get 4. So it's x squared plus 4x plus 4 minus 4 plus 5. Let's factor it down. X and x, 2 and 2, so it would be x plus 2 squared minus 4 plus 1 is plus 1. So this is the answer. It's not that hard. Okay. And then if they ask you to find the y-intercepts on vertex form, you know how to do it, right? This is the y-intercept, right? And the vertex points. Sorry, the y-intercept is not this. The vertex points are this. So the vertex is -2 and 1, and the y is 5. Why? Because if you replace this with 0, x with 0, it would be 2 squared, which is 4 plus 1, so it's 5. Okay, now let's move on to intersection of parabola and line. So, okay, so there are 3 cases in this topic. So there are 3 cases. There are 3 cases. The first one is called cutting. The second one is called touching. And the third one is called missing. So, what do I mean by cutting and touching and missing? Okay, so if the graph looks something like this, you see that if there are 2 points, here that are cutting the x-axis, then this whole case is called the cutting. But then if the graph is just cutting the x-axis with 1 point, see, it's just 1 point, then this case is called touching. So basically the parabola is just touching the x-axis. But then if the graph is like this, then in this case we see that there are no points that is touching the x-axis, right? Or any axis. So basically this is called missing. That's it. It's pretty much that's it. So there are ways to find out if the graph is cutting or touching or missing without graphing or sketching, and that way is by using the discriminate. So let me give an example. If they say that find the intersection points of x squared minus 6x minus 10 and 2x plus 10, what you do is that you would write x squared minus 6x minus 10 equals to 2x plus 10. And then you kind of rearrange it into one formula, which would be x squared minus 6x minus 2x minus 10 equals to 0. So this would be x squared minus 8x minus 20x equals to 0. So now you're left with one formula, right? I mean one equation. So what you do is that you would write delta equals to b squared minus 4ac. And we know that b is 8, so b squared is 64 minus 4 times 1 times negative 20, which gives us plus 80. Sorry about that. So where was I? Okay, so it's 64 plus 80, which would give you 144. So we know that delta is greater than 0, which would mean that there are 2 points, right? Because if delta is greater than 0, then there are 2 different answers. So let's check it. Let me erase these. So let's check it. So if x squared minus 8x minus 20, the formula that we got, equals to 0. If we factorize this, we would see it's x minus 10 and x plus 2 equals to 0. So x equals to 10 or x equals to negative 2. See, the discriminant told us that we got 2 different answers, and the discriminant was right. We got 2 different answers. Let's take a look at an example. Okay, so where is the pen? Oh, okay. So here's example. It's sketch y equals to negative x plus 1 squared plus 2. So in this one you don't really have to find the x-intercepts, just the y-intercepts are important. So the y-intercepts, I said that in order to find the y-intercepts you need to replace x with 0. So what you would do in this case is y equals to negative 0 plus 1 square plus 2. So negative 1 plus 2, which would be 1. So in this case the y-intercept is 1. Now let's take a look at how to find the x-intercept, the vertex points. The vertex. And I said here h and k give you x-intercepts, right? So here, this is h and this is k. So the vertex are negative 1 and 2. Yeah. In this one, the one that is inside the bracket, if you open it up, it would be negative 1, right? So yeah. And this would be 2. So these are the vertex points. And if you want to sketch the graph, it would be something like this. Okay. Since the y-intercept is 1, since the x-coordinate of vertex is 1, the axis of symmetry is 1 too. So axis of symmetry is x equals to negative 1, which would be here, right? So this is the Vx, and Vy is 2, so it's somewhere here. So this is a turning point. So the graph would be something like this. Okay. Now let's move on to conversion of the second form to the third form. Okay, what I mean by this is converting y equals to ax squared plus bx plus c into y equals to x plus h squared plus k. So the best way to explain this is by doing examples. So let's do an example. Here, if we have y equals to x squared plus bx plus 4, and they asked us to write it in the vertex form, which means this right here. What you do is that you basically kind of use the completing the square method, but then we don't have the other side of the equation, so you just skip it on the same side of the equation. So it would be like this: x squared plus 2x plus the question mark c minus the question mark c plus 4. So 2 divided by 2, because b is 2 here, so 2 divided by 2 square gives you 1. So you just replace the question marks with 1. So it would be x squared plus 2x plus 1 minus 1 plus 4. So you kind of this equation right here is, let me change the color so you won't be confused with one. This equation is kind of separated right here. So you change this into this, and then the plus k would be this right here. So it would be x plus 1 square. So in order to get this, we can just use this side of the equation and do the factoring, which would be x times 1 times 1, which would give you plus 2k. So it would be x plus 1 square, and minus 1 plus 4 gives you plus 3. So basically you're left with this. So is this the vertex form or not? Yes, it is. That's it. It's this easy. Let's do one more example. So if they give you something like y equals to x squared plus 4x plus 5, so the first thing you would do is do the question mark part. X squared plus 4x plus question mark plus 5, minus the question mark plus 5. So here, this is the separated part, right? This is the k part. Okay, so now we would take b, which is 4. 4 divided by 2 gives you 2. When you square it, you would get 4. So it's x squared plus 4x plus 4 minus 4 plus 5. Let's factor it down. X and x, 2 and 2, so it would be x plus 2 squared minus 4 plus 1 is plus 1. So this is the answer. It's not that hard. Okay. And then if they ask you to find the y-intercepts on vertex form, you know how to do it, right? This is the y-intercept, right? And the vertex points, sorry, the y-intercept is not this. The vertex points are this. So the vertex is -2 and 1, and the y is 5. Why? Because if you replace this with 0, x with 0, it would be 2 squared, which is 4 plus 1, so it's 5. Okay, now let's move on to intersection of parabola and line. So, okay, so there are 3 cases in this topic. So there are 3 cases. There are 3 cases. The first one is called cutting. The second one is called touching. And the third one is called missing. So, what do I mean by cutting and touching and missing? Okay, so if the graph looks something like this, you see that if there are 2 points, here that are cutting the x-axis, then this whole case is called the cutting. But then if the graph is just cutting the x-axis with 1 point, see, it's just 1 point, then this case is called touching. So basically the parabola is just touching the x-axis. But then if the graph is like this, then in this case we see that there are no points that is touching the x-axis, right? Or any axis. So basically this is called missing. That's it. It's pretty much that's it. So there are ways to find out if the graph is cutting or touching or missing without graphing or sketching, and that way is by using the discriminate. So let me give an example. If they say that find the intersection points of x squared minus 6x minus 10 and 2x plus 10, what you do is that you would write x squared minus 6x minus 10 equals to 2x plus 10. And then you kind of rearrange it into one formula, which would be x squared minus 6x minus 2x minus 10 equals to 0. So this would be x squared minus 8x minus 20x equals to 0. So now you're left with one formula, right? I mean one equation. So what you do is that you would write delta equals to b squared minus 4ac. And we know that b is 8, so b squared is 64 minus 4 times 1 times negative 20, which gives us plus 80. Sorry about that. So where was I? Okay, so it's 64 plus 80, which would give you 144. So we know that delta is greater than 0 which would mean that there are 2 points, right? Because if delta is greater than 0, then there are 2 different answers. So let's check it. Let me erase these. So let's check it. So if x squared minus 8x minus 20, the formula that we got, equals to 0. If we factorize this, we would see it's x minus 10 and x plus 2 equals to 0. So x equals to 10 or x equals to negative 2. See, the discriminant told us that we got 2 different answers, and the discriminant was right. We got 2 different answers. This means that in this case we got the graph as cutting because we got 2 different points, 2 roots. So that means the graph would be cutting the axis on 2 different points. So in order to find the cutting or touching or missing, you need to use the discriminant. Okay, now let's move on to problem solving with quadratics. So we all know what problem solving is solving problem. Lol, no. Okay, yes. Here I have an example that says, okay, let's take a rectangle. This would be the L, this would be the W, the length and width. And if the area of this rectangle is 66 centimeters square, and if the question says that the length is 5 centimeter longer than the width, and if it asks us to find L and W. Okay, you could probably find this by using normal ways, but then we want to solve this question by using quadratics. So what you need to do is, sorry about that. What you need to do, okay, here, I'm gonna erase this since it takes a lot of space. We know that area is 66 and the length is 5 centimeters longer than the width. Okay, so the area is 66, A equals to 66 centimeters square, and the area is x plus 5. The length is x plus 5 because it's 5 centimeters longer than the width. So the width would be x and the length would be x plus 5. We know that in order to find the area, we have the formula of formula of L times W, which would give us the area, right? Okay, so now we have this and we have a little of these two, so we will just substitute our values in the formula. So it would be 66 equals to x times x plus 5. So what we would end up with is 66 equals to x squared plus 5x. So now let's move 66 to that side of the equation. It would be x squared plus 5x minus 66 equals to 0. See, we are getting a quadratic equation. So what we would do is use the cross multiplication, factoring. So what gives us 66? It's 11 and 6. Yeah, but does 11 and 6 give us 5x? It does. This can be plus and this can be minus. So it would be x plus 11 and x minus 6 equals to 0. So x plus 11 equals to 0, or x minus 6 equals to 0. So x equals to negative 11 and x equals to 6. We know that there can be one possible answer for x, and it cannot be 0 because length is something that it cannot be negative. So we know that our possible answer is x equals to 6. So now we would substitute the value of x with our x plus 5 and x. So the length would be x plus 5. The length was x plus 5, right? So it would be 6 plus 5, which would give us 11. So this is the length. And the width would be 6 itself. It's this easy. Okay. Oops. Okay, let's solve one more problem so we are pretty clear on this topic. Okay. Imagine the question asks us that the product of two consecutive positive numbers is 182. And now it asks us to find the numbers. Find the numbers. So we know that consecutive means that one after another, right? So we know that it would be like this. It would be x and then x plus 1 equals to 182, right? It's one consecutive after another. So we would do the same thing as we did in the last question. Time this with this and this with this. So it would be x squared plus x, and then move this to this side. So it would be 182 equals to 0. And now we would factorize it. What times what gives us 182? 14 and 13 gives us 182. And we know that we want positive x, right? So this would be positive, this would be negative. So it will be x plus 14 and x minus 13 equals to 0. So x equals to negative 14 and x equals to 13, or actually so our answers, we know that consecutive numbers cannot be negative, because here in the question it says positive. So this is not the answer. So the answer is x equals to 13. So now let's replace it with x and x plus 1. So x would be 13 and x plus 1 equals to 13. It would be x sorry I mean x plus 1, it would be it would be 13 plus 1, so it would be x equals to 14. So our answers are 13 and 14. Okay, great. Now let's move on to quadratic optimization. So let's define what optimization means. Optimization means minimum and maximum. So this kind of has to do with graphs. We learned that if a is greater than 0, we get a graph which is upwards, right? So if the graph is upwards, we know that this point right here is the vertex. Not only the vertex, but also the minimum point. Since it's upwards, this is the lowest point on the graph, right? So this would be the minimum point. And we know that if a is less than 0, we get a graph which looks like this. And if the vertex is here, of course the vertex is here, we know that this point would be our maximum point. So pretty much quadratic optimization is all about the minimum and the maximum points. So if we have to find the vertex points, okay, let's do an example. If they ask us to find the maximum or minimum value of the equation of the quadratics right here, like something like y equals to x squared plus 6x plus 3. Since this is the second form, we know that in order to find the x vertex, we have to use the formula of negative b divided by 2a, right? So it would be negative 6 divided by 2 times 1, it would be 3. Actually, negative 3. We know that this is our x vertex, and we also know that it is our minimum point because the graph right here is positive, right? So it's upwards. So that means our vertex, it would be our minimum point.